The last example that we want to focus in on in section 5.3 is example 9. And in this case, we're going to have two logs to start with in the problem. We haven't seen that just yet, and so this is something new. If you remember when we solved for x's a while back, one of our strategies was to make sure that all of our x's ended up on the same side of the equal sign so that we could get an answer for x. It's no different when it comes to logs. So the first step we want to take in any log problem when there's multiple logs is to gather all of our logs together on the same side. So I'm going to keep 3 where it's at on the left-hand side here, and I'm going to keep the natural log of x plus 4 where it's at on the right-hand side. Again, I'm looking at example 9 on page 351. I'm going to take natural log of x, and I'm going to bring it over, and it's going to become negative natural log of x. Now what I get to do is I have a natural log and a subtraction between them. This is totally quotient rule. And it says if you have the same base of log and a subtraction, you can consolidate them to one log with a division. And that's what I'm going to do then. So 3 is still going to be 3 on the left. And on the right-hand side, we're going to have one natural log. The numerator is going to be x plus 4. The denominator is going to be x. Awesome. Now we can invoke the definition of log because we have one log and it equals something, much like our definition of log, as in we have a log that equals something. In our case, the base of this natural log is e. So to rewrite this in exponential form, it's going to say e to the power of 3 is equal to x plus 4 over x. Great, I like this. All right, now we have to solve for x. And so the first thing we want to do is we want to get rid of our fraction. So we're going to multiply x on both sides here. That's going to give us x e to the 3 on the left, and it's going to give us just x plus 4 on the right. Now, at the beginning of this problem, we talked about how to solve for x's in this manner, right? We gather all of our x's on the same side, and so let's do that. Let's take this x that's on the right with the 4 and bring it to the left here so it could be with this x e3. So that's going to be x e3 minus x, which is the x from the right-hand side, and it equals 4. All right, so now on the left-hand side, these two items have something in common. They have x in common, so let's factor that x out. So that's going to give me e to the 3 minus 1, and the whole thing's still equal to 4. Now to solve for x, I need to divide both sides by this e3 minus 1. And that's how we're going to find x. X is going to be 4 divided by e cubed minus 1. All right, so this is a calculator exercise again. So we take our calculator out, clear off anything we don't need, and we get to say 4 divided by parenthesis e. So I need my second and ln. That's going to give me e, so e3. I'm going to make sure I come off of the power, so a little arrow will do that. And I can say minus 1. Close parenthesis, and this thing's ready to hit enter. Hit enter, and we have our answer, which is 2.095, or rounding 0.21 for us. Again, like anything else we've talked about this far in this chapter, in this section, it's checkable. I could go back to the original and I could say, hey, give me the natural log of 0.21 plus 3, and it should equal the natural log of 0.21 plus 4 here.